Hey there, Year 901, Mr. Herman here, and this is exercise 4D bearings. Now this exercise was already taught to a few students last week on Thursday during face-to-face teaching. If you want, you can watch this video again, but if you understand the premise of it, by all means continue on with the set questions. There are two parts to this exercise. The first part is just going to be looking at the basics of bearings and understanding the true works of what lies within bearings, and then the second part looks at bearings in conjunction with trigonometry. For now, let's look at bearings, and the learning goals for this one is to understand how true bearings are measured and written. The success criteria for the first part is to be able to state a true bearing and its opposite direction, also known as a back bearing, from a diagram. And the second part is primarily going to be looking at how to apply bearings in word problems using a diagram and trigonometry. So bearings, there are different definitions for the word bearings, both in maths and non-maths context. In non-maths context, we think of bearings as getting our positionings correct when we're in the world. And if you want to take a literal meaning from it, say for instance someone was going to start a new job somewhere and they wanted to get their bearings straight, that term or expression just means that they have to get used to the surroundings of being in a new workplace. Maybe they might find it hard to understand. In the maths context, bearings primarily focuses on a starting position, an ending position, and a rotation of some sort. And how we look or how we use a rotation, there's a few fundamental rules that follows. So right here I have a compass measured north, south, east, west, which is obviously taken from a compass that we use to navigate in real life, where north points directly when using a compass to the North Pole through magnets. Now with north, south, east, west, there is a degree that is associated with this. Okay, so north is our starting point, and this can be written as both 0, 0, 0 degrees or 360 degrees, and we'll look at as to why 360 degrees in a second. But north starts at 0, 0, 0 degrees. So if you're going to copy this into your books, this is the compass or the navigation that you want to write with the associated north, south, east, west, and the relative degrees associated with it. There are three things that we need to consider when measuring in bearings. The first one is that bearings are measured. Bearings are measured from true north. True north. That just means that when we are to measure from an origin or from a spot of some sort, we pretend that there is a line that's pointing straight north here. Okay, now this will make sense when we put this into context, but just remember this is our starting point. Okay, so bearings are measured from true north. The second thing that we have to consider is that bearings, or true bearings, are measured anti-clockwise. They're measured anti-clockwise. Or in other words, starting from true north, we rotate around like that. Okay, and this is why we can see that the measurements incrementally or go up in increments in an anti-clockwise nature. The third thing about bearings is that the bearing units are written as three numbers, and always three numbers. The bearing units are written as three numbers with a degree symbol. And to put the degree symbol, I'll just put that there. that's to indicate degrees, and ending with the letter T. Ending with the letter T. Now we say the letter T because the letter T just stands for the word true. Okay, so whenever we're talking about bearings, generally speaking, we're always talking about the term true bearings. And when we say true, this true just indicates that we are talking about that it's starting at true north, because sometimes bearings can start at a different direction depending on what type of bearings you have, but the most common bearing and the ones that we'll be looking into with this exercise is true bearings. So we always end with a T at the end of this. Now these three facts we're going to use in order to tackle questions, and just as a little fun fact, this is the reason why the navigation program that you use to see which classes you have to go to is called Compass, because it has to do with navigation. Alright, let's look at some exercise examples. Now, there's a few things that we'll be looking into with this question. A is relatively simple, but B can get a bit tricky when it comes to the explanation, but there is a way to tackle this type of question by using a simple calculation. Now for those of you that are watching this and you've already seen this part at school, you haven't seen the second part of how to actually calculate these type of bearings, these Mach bearings, because we ran out of time. Okay, so it's in your best interest to have a look at how we tackle this. Okay, so the questions that we have here are relating to this compass here. And namely, we've got 4 points A, B, C, and D. Now, not all information has been given within here, so there's a bit of working out, fairly simple working out, but working out regardless that we need to consider. So the first question here, A, B, C, D are 4 points as shown. A, we're going to give the true bearings of each point from the origin O, which is here in the middle in this diagram. So we're going to give the true bearing of each point. So in other words, from the origin O, this is our starting point, and we're going to get the true bearings of A, B, C, and D. So what this is saying, that if we start at the origin O, looking into the first fact that we always start at due north, second fact, we go anti-clockwise. This point from there to there, we're looking for this regarding a bearing. So if our origin is here and A is here, what's this true bearing? Well, if we know that within here there's a 90-degree angle, and this has already been given as 35 degrees, the difference of 90 and 35 will give me what this angle is here. So, true bearing. True bearing of A from, now I should write point A, of point A, try that again, yeah, of point A from O, point O, and the point O is just the origin, is equal to, and we've just got to show the working out. And this is just 90 degrees, take away 35 degrees. So 90 degrees, take away 35 degrees, will end up with 55 degrees. Now we just got to remember that a third fact that we have to consider is that it is written as 3 digits. So we've got to remember 0 in the front, degree symbol, and then the letter T, to indicate that it's true bearing, or to indicate that we've measured from true north. So true bearing of point A from point O is just 90 take away 35, which is 55 degrees true bearing. To get point B, we're going to do true bearing. I'm just going to write TB now. So TB just equals true bearing. should write it consistently. OCD is kicking in. Gotta love these late night maths tutorials. Okay, so TB of point B from point O. This is starting at over here, scooping around, but this time we're going to keep going until we stop at point B. So still measuring from true north, but we're just rotating until we hit point B. And it doesn't matter where you start and where you hit within the slide, this will always measure the same angle. So in this case, we're doing 90 degrees plus an additional 45, because this 45 degrees has been given here, to get to point B. So the working out for this is 90 degrees plus 45 degrees. And this will give me 135 degrees true bearing. And that's all there is to it. We'll do C and D. So true bearing of point C from point O, or point origin. We're going to scoop all the way around until we get to C here. So this is just going to be this straight line, which is 180, plus this degree here. We don't know what this degree is here, but we do know that if this is 30, this has to be 60 degrees to make this corner equal 90. So it's kind of like what we did in the opposite within this quadrant here, but we're just working it out in that quadrant. 90 minus 30 to get 60. So this is 180 plus the additional 60, and this will give me 240 degrees true bearing. And the fourth one, true bearing of point D, whoops, okay, from point origin. And this is going to be equal to scooping all the way around 90, 180, 270, plus an additional 70 degrees. So we're starting at true north, going all the way around 90, 180, 270, plus 70. So this working out is 270. Yep, that's gone too far. Oh my goodness. Try that again. 270 plus the 70. This is equal to 340 degrees true bearing. So true bearings, when you have your origin point O, start within the middle of this. This is simple. Okay, there's just a little bit of working out whether it's addition or subtraction that you have to consider. Where it gets tricky is when we look into what's called back bearings. So back bearings are these two examples here. We're going to get the true bearing of the origin from A. So in the previous questions rather, we were looking at the origin coming from the origin. Now we're going to the origin from A. So what does that actually mean? So I'm just going to erase this here quickly. Yep. Let's try that again. Accidentally wrote on top of the layer, so I just got a new one. Video editing, woo! So what we're doing is we're given the true bearing of the origin from A. So what we're used to is measuring true north from the origin, because the origin conveniently is just already placed here within the line of true north. But this true north line doesn't actually lie within the A, but what we can do is we can draw a compass on here. We can draw a compass on here, like so, and have our north here, south, east and west. And what we're actually looking for is, now this is our origin. We're going to go from here and rotate around, starting true north, until we get to this line here. So this is effectively the opposite direction of this line here. Okay, so instead of going from there to there, we're going to pretend that a compass is at the point A, and we're going to rotate, starting at true north, rotate until we hit this line, and we just got to work out what that is. Well, that is effectively 180 plus whatever that degree is within there. What is that degree? Well, we already know that if this is 35, that little angle here, which is its complement, or alternate angle, sorry, is also 35. Meaning this angle within here and this angle within here, their alternate angles, they also have to be the same. We already worked this out. This is 55 degrees. Okay, we worked that already, meaning this here, that small little angle within here, also has to be 55 degrees. Okay, so to get the true bearing of O from A, this is going to be 180 degrees plus an additional 55 degrees. So we're going to get the true bearing of O from A. So to answer question B, to get the true bearing, I'm just going to do shortcut notation now. True bearing of the origin from A now. So we're going from different spot A. What we're going to do is 180 degrees plus the 55 degrees, which is what we initially said. So remember, there's our line. We're going around until we hit here. Okay, this ends up being 235 degrees true bearing. Now, to get O from D, there's a different case. This is I. So I. To get O from D, it's the same case. Instead of going all the way around to here, we're just going to pretend that this compass exists here. And all we're going to do is again start at true north and keep going until we hit this line here. Okay, so we're going to go all the way around until we hit this line here. To get that angle, there are different ways. We can do 90 plus whatever this complement angle is here, which ends up being 70 degrees anyways, because it's an alternate of that. So that's just 90 plus 70 degrees. So true bearing of O from D, from D is just equal to 90 degrees plus an alternate angle of 70 degrees, which ends up being 160 degrees true bearing. Now, a much simpler way of working out back bearings when you have a different from place is using this little diagram here. Now, this is what I did not teach within class for those who are watching. If your bearing that you've initially found is within the first two quadrants, or the first half on the right hand side, so from 0 or 360 to 180, to get the back bearing of it, you just add 180 degrees to it, which is already what we did within the first one. To get the back bearing of any point within the second quadrant, so two quadrants, the second half, so 180 to 360 or back to 0, you just subtract 180. So let's have a look. We have the true bearing of A from the origin O. So our origin was here, and from O to A was 55 degrees, so like roughly there. So there's point A, there's our origin. This degree here was 55 degrees. Now, to get the true bearing of O from A, okay, so that thing that we worked out when we scoop around, because this is within the first half, we're just going to get this 55 degrees and just add 180 to it. Okay, just add 180 to it. So this ends up being the 235 degrees, 235 degrees that we initially got in the first place. Because what's happening is that this angle that we're finding here to get the backwards one, this is technically just line is just continuing on, yeah. So we're almost getting the backwards version of this, starting from here and going around. This is just the backwards version, and this straight line is 180 degrees. So all we're doing is getting this 55 degrees and adding 180 degrees here to get our 235. That's where the maths behind it comes from, okay? And if it's within the second half, which we have in this example here, the true bearing of D from the origin, so we started the origin, which is here, 340 degrees is roughly there-ish, give or take. So this whole thing that scoops right around is 340 degrees. We are looking for the opposite of this, the back bearing of this, the true bearing of the origin from D. Again, this is just the backwards version of this here. And again, this degree that we have here, from there to there, is 180 degrees. But we're going back, we're going backwards. So we have to get whatever this this 340 degrees in the first place and kind of backtrack a bit, exactly 180 degrees, so we get back to this point here. So this is where we have 340, take away 180, and this is where we get 160 degrees true bearing, which is what we got here. We worked it out another way, but we ended up with the same answer, 160 degrees. So to make life easier for you, I'm going to just erase all this jargon here, make it easier to read. If your bearing initially started within this half here, just add 180 degrees to get its back bearing, or to get the different origin spot, or if it's inversed. If it's within the second half, you subtract 180 degrees. This is the first part. The second part will be in the next video, which will be working on a worded question that is that involves trigonometry. So trying to get this under 25, which I did. See you in the next video. See you later.